So hello, in this video we're going to handle matrices, and quickly let's handle matrices. This is a topic in paper 2 of high school diploma in Kenya. Perhaps it's a different it's tested in a different way in other schools, but I know in Kenya it's a topic that is tested in paper 2. So I'll start by giving mathematically defining a matrix. So a matrix is any enclosed item B, C, and D in this format, where all these four are what? Are elements. So this so we have triangular matrix. Perhaps this one I'll teach in advanced level, because this is in campus, this is in uni. We have a square matrix, and for high school the limit n should be less than, where this one n should be less than or equal to 2, and perhaps greater than 1. So you can actually have this greater than 1 but less than or equal to 2. This is the limit for high school, but in campus, you go to something up to 5, even 6. You can even get a matrix that has A, B, C, D, E, several. So that's for high school diploma. Basically the maximum you can handle is up to 2 elements. So you handle a square matrix. So let me define a square matrix. So a square matrix takes the form n by n, where n is an element of natural numbers. So we proceed and say so perhaps so a 2 by 2 matrix an example can be let me see, I think this one can work. So can be 4, 2, 3, 6, that's a 2 by 2 matrix. You can give in a 1 by 1 matrix, 1, You can also have you can also have a matrix in the form of, now this is not a square matrix, but the form of n by n, where both m and n are less than or equal to 2. How? You can be given this way. Let's proceed. 2 by 1. How do you get that? So this is it's written this way. Let's say A, B. This is a matrix as well. Then you can have 2 by 2. This is another form of a square matrix. It is A, B, C, and D. Then you can have 2 by 3 matrix. I think sometimes these numbers can go beyond, but mostly you'll find something close to the maximum you can get. Actually is 2, 4, 1, 8, 0, 3. This is a 2 by 3 matrix. You can still have a 3 by 3, which will be 1 2 3 4 5 6 7 8 9. So you understand by n by m, n and n m, where m is normally the row. This is the column. Yeah, so row by column. So we proceed and give the rules now, the rules of matrices. So we say rules, or I don't know, do we call them what? It should be rules, just rules, operations in matrices. So the first one, I'll say should be, we put white, yeah, gray, so the first rule should be addition, and by addition, this is what it means. So given a matrix in this form, let me change. So given a matrix in the form of A, B, C, and D, then perhaps plus let's say E, F, G, and H. So when given such a and you're told to add, so what is it? So how do we add this? Yeah, so we proceed and say, so let's add it. So this summation, do this. So summation here, that is A plus B, assuming in this case I'm assuming that this is A, then this is B. So A plus B will be given by so this is the general format of adding. So A plus B. So A, the addition happens between elements with the same position in the matrices. How? So in this case, our A will add with E to have A plus E. That is the first element. Then the second element here, it's B plus F. So B plus F. Yeah. Then the third element will be C plus G, because they're in the same position. So C plus G. Then the last element will be D plus H. So D plus H. So this is the law of addition. Law of addition. So in subtraction, the only thing that changes is the sign. The sign. To have, so where this M and minus B, then you take it's A minus E. Here it's B minus F. Here is C minus G. And then here is D minus H. And then notice also the order. The order. Because the direction in which you add those elements won't be the same, depending on what operation you're handling. If you make a mistake and then interchange them, A plus B is not the same as B plus A. Perhaps it might seem okay here, but in other places, in other operations like multiplication, you really have to ensure that you put it in terms of the order given. If it's A plus B, please ensure it's A plus B. If it is B plus A, then put it B plus A. Don't change the format. So we proceed and say, so let's proceed. So let's go to multiplication. This is where the trick is, and I want you to pick it from there. So let me go to multiplication. So in multiplication, so multiplication, So in multiplication, so what happens in matrices, the rule states that when given a matrix, this is A, in the form of A, B, C, and D, I want it to be keen here, that multiplied by a matrix B, that is matrix B, that is E, F, G, and H, then matrices A and B with the following elements. The product will be given by A times E, that's added to B times G. By this I mean the first row multiplied by this first column. That's how you multiply. So A picks E, B picks G. The second element will be given by A times F added to B times H. So it's still the first row with the second column. Then the third element will be given by C times E added to D times G. Here is the second row multiplied by the first column. So the final element will be given by C times F added to D times H. Yeah, so this is the rule. It will never change. You are the one who will forget, but this is the rule forever and forever. So let's do an example. An example so that maybe that can be cemented. So e.g., given that A equals to 5, 3, 2, 9, and B equals to 1, 4, 3, 2, find A, B. So they simply mean you find the product. So how do you do that? Let's go to, now let's rearrange our elements. So this is so AB here will be given by, let's put the matrix together, 5, 3, 2, 9, then multiplied by, there's a dot here, you can put a dot, multiplied by 1, 4, 3, 2. So this should give you, let's go down and say, this should give us, so it's the first, let me change the font. So as I said, it's the first row multiplied by the first column. Then of course first row, second column, second row, first column, second row, and second column. So we proceed and say, so this will give us 5 times 1. So this will be 5 times 1 added to 3 times 3. That's the first element. The second element will be given by 5 times 4 added to 3 times 2. That's the second element. The third element will be given by 2 multiplied by 1 added to 9 multiplied by 3. Then the final element will be given by 2 multiplied by 4 added to 9 multiplied by 2. So this is the product. and that's how you apply product rule. So let's get the final answer. This gives us, this is 5 plus 3 times 3 is 9, that is 14. That's the first element. Then 5 times 4 is 20, 3 times 2 is 6, so 20 plus 6, that is 26. 2 times 1, 2, 9 times 3, 27, so 2 plus 27, that is 29. Then 2 times 4 is 8, 9 times 2 is 18, so 8 plus 18 is 26. And that is our final product of what? Of A times B. That's how you solve a matrix. So if you understand this, by the way, you're sorted. Trust you me, if you understand how to multiply a matrix, then you're sorted forever. Now I want to introduce something called the unit matrix. So a unit matrix is a matrix. So let me introduce it here. Let me call it this is so a unit matrix. Unit matrix. So a unit matrix is a matrix whose absolute value, whose determinant is 1. And normally, so an example, actually this is not an example, but mostly this is what is normally used. So 1, 0, 0, 1. So this is a unit matrix. How do you know it's a unit matrix? So assuming this matrix is called B, so therefore now this brings us to another concept of finding what? Of finding determinants. Determinants. Yeah. So a determinant of a matrix given in this format, given in form of A, B, C, and D. A determinant of such a matrix, and a determinant is shown by these two absolute value marks, because a determinant must or has to be positive. So the determinant is found by A times D subtract C times B. That is simple how to find a determinant. Therefore, the determinant of a unit matrix, let's calculate it. So B will be given by, this is the determinant, will be given by 1 times 1 minus 0 times 0. So 0 by 0, this is 0. 1 times 1 is 1. So 1 minus 0 equals to what? 1. So this is a unit matrix. So again, so there's another type of matrix. So this is a unit matrix whose absolute value has to be 1. Not really absolute value, but the determinant has to be 1. So that brings us to another concept called the unit matrix. Unit matrix. I mean, sorry, not unit matrix, but that brings us to another concept of a singular matrix. And what does it mean for a singular matrix? So a singular matrix, it's the determinant. So it's determinant. So assuming a given matrix, so given A as a matrix, then for a singular matrix, A, determinant of A, which is the determinant of A, should be given by, determinant of A is always 0. For what? For a singular matrix. For a singular matrix. This means therefore that so for instance, we're given a question. We're given a question. You're told so matrix A is suspected to be a singular matrix with the following elements. So x, 2, 3, -1. Then you're told is suspected to be a singular matrix. So you're told find x. So by definition, a singular matrix has to have a determinant of 0. So that means, therefore, the determinant of this, let's proceed and say, the determinant of this will be, so determinant of A in this case will be given by x times -1 minus 3 times 2. But all this, so this is a determinant, but we know that the determinant of A equals to 0. So we equate this to 0. So that gives us what? So this means, therefore, that so x minus x times -1 is -x, then minus 3 times 2 is 6 equals to 0. There, what is the value of x? So -x equals to, we take -x to the other side, to have equals to positive 6 actually. So divide by -1, that by -1. This means therefore that our x equals to positive 6 over -1, which is -6. So that's how you find, that's where now the concept of singular matrix will always apply. They will give you some unknowns, and then test you on really if you understood what a singular matrix is. Then sometimes they always want you to apply quadratic equations. They want you to use factorization or any other method to find x, because sometimes they might give you another x that if you multiply them, you get an x squared. Somehow they know how to manipulate that to get into a quadratic equation. So as I told you in my video on quadratic equations, I told you understanding quadratic equations solves a quarter of your problems in high school, because most of the questions will want you to apply quadratic equations. Now, this is a common question. They'll give you in KCSE. They like that. In high school diploma, that is the final exam. So I insist on you grasping this. If you don't understand, please let me know on the comment section, and I'll explain duly. I'll also give you my contacts if you want to, just to get the assistance that you need. Something else is that you need to join me on my next video. I'll touch something on inverse matrix and how you can solve simultaneous equations using the matrix method. So in my next video, I'll be handling, let me just leave with that, I'll be handling inverse matrix and solving simultaneous equations